For my 50th episode, we are celebrating 50 years of the Nakagin Capsule Tower gracing the skyline of the Ginza district in Tokyo, although sadly it is in the process of being torn down. There's a photo that I took of it. Designed by Kisho Kurokawa and constructed in 1972, it was built on the ideas of metabolism, an idea where buildings and infrastructure can grow and adapt to our changing needs. As such, it was envisaged that the capsules on the building would be removed and replaced with newer units as needed over the life of the building. However, that vision was never realized. This was largely due to a design flaw that prevented any capsules from being removed until all above it are also removed. That costs too much, and it is too difficult to get all of the above residents and owners to agree. Each capsule is a one-room tiny apartment, 10 meters squared floor area. They contain a bathroom of the compact unit bath style common in tiny Japanese apartments and hotels, which has a tub with a shower, an area you can stand, toilet and sink. The room has no kitchen. One wall is covered by built-in furniture that includes a closet with hanging space and a mirror, a sink which was optional, not all rooms had that. There's a fridge which is probably also optional, which can go there, an air conditioner. There's a fold-down desk here, and there's various storage cupboards. There are built-in electronic appliances. These were also options. There's a TV, a stereo radio, a state-of-the-art open-reel tape recorder, telephone, clock, bedhead light, speakers there for the radio. The bed was built in part of the room, and it's quite narrow. There's extra storage under there, and there's a stool which sits beside it, and that's used when you're using the desk. There was a calculator built in as well to the desk, light above it, more storage. The room has one large round window that cannot be opened to the outside. It's 1.3 meters diameter. These apartments were intended for business people to stay close to work during the week, then travel home to houses out of the city at weekends. The lack of a kitchen is of little concern due to the location. It's not far from restaurants, vending machines, and convenience stores. There were two main room configurations, one that has the door on the end and the other that has the door on the side. When the door's on the side, the wall unit is split into two parts on two of the walls. There was an issue with the flat tops of the capsules that allowed rainwater to pool and leak in, and also the seal between the capsule and the concrete tower has gone bad over the years, and that allows water to get in between them and leak into the capsule. The surfaces connected to the capsule are flexible and disconnectable to allow the removal of the capsules. However, it all ended up in inaccessible space between the capsules, and that has prevented access for maintenance. This is the brochure that advertised the building before it was constructed. It only contains drawings because the building didn't exist at that time. It's got the specifications, services that were provided, and the floor layouts. And here it lists the different options that you can have, like the TV, the radio, the tape deck, the colors that the room could be in. Let's take a closer look at the electrical fittings and then the electronics that are in the room. Within the bathroom, there is a single electrical outlet, and that is a Toshiba brand, and it has a screw-on cap over the socket to reduce water splashing into it. The other outlets and light switches in the room are made by National, more commonly known around the world as Panasonic. They're from the Haikaku series, which translates to high angle. These were manufactured from the 50s to early 70s. There is a 2-socket outlet by the desk and another on the wall to the left of the bathroom door. Additionally, there's another one behind the TV and behind where the audio equipment is in the wall unit. There are 3 switches by the door. That's for the room light, bathroom light, and the extractor fan. At the head of the bed are additional switches, a 2-way for the room light and the above head light. It also includes options that allow the alarm clock to control the TV and the radio. Those switches are also from the high angle series. Instead of the usual cover, they've got a brushed aluminium custom plate over the top of them with text. So it's just the standard one of these. So that's made up by one of these plates, and then the switches that they hook in one side, and then you use your flat screwdriver there to squeeze that bit over to lock it in place. So it's 2 sets of that with some blanks. I'm not sure why they put the blanks. They could have just fitted 2 switches and then not had 3 cutouts per thing. It's a bit strange, but yeah, these older style use screw terminals to attach the wires. And there's the current model of the Panasonic stuff. It's all push-in terminals. Similar to these outlets, there's doubles, but you could also get triples, and you can also get these single units, so you can build up a collection of switches and outlets, and there's also neon lights and other bits and pieces that you can have. In the rooms that have the door on the long wall, they don't have their double outlet next to the desk. Instead they have this type, which is a remote mountable outlet, which you can build into furniture, like screw that into a hole and then put the plate over the top of it, and then that gets plugged in somewhere. And that's closer to the configuration that was shown in the plans. Not in this book, but in another drawing that I found. They showed the outlet. There is a flip clock mounted in the unit, similar to this one. The one they used is Copal 701, whereas this is an RP207. This is a Japanese model because it's got the switch that switches between 50 and 60 Hertz, which you need to use depending on which region you're living in Japan. The US market version would just be a 60 Hertz. So the one they used has got the knobs on this side, and they've been replaced with, as these come out, replaced with larger ones that can pop up through the wood. And somehow they've been connected into the alarm circuit, which I'm not sure how that was managed. What you can do is set the switches so that when the alarm comes up, it will turn on the radio or the TV for you, which is quite nice. Let's check this. Sitting at 102 volts at the moment. I'll plug the clock in. 1.2 watts. And there's a little wheel in there that you can see turning, and there's also a neon light down there. You can sort of see it. On the 701 model, that's a larger window there. When the alarm goes off on this one, makes a buzzing noise created by solenoid effect. It's got a really nice little plug on it. Good old Japanese stuff. Unrelated, but one thing I have noticed with Japanese cables is that there's always or usually, there is a small ridge down the insulation, and that will indicate the neutral side, or white as it would be called. The larger pin on the polarized plug will have the ridge, so even though the plugs are not polarized, you can work out which way to put it by feeling for that ridge, and you put that into the larger pin, and then a polarized output will actually be connected around the right way. That's the same on this. They, instead of It's usually indicated as W for the white wire, but unusually on this one they do call it N for the neutral, and that is connected to the core that has the ridge down it, so you would know that that goes into the wider slot in the outlet, and then it would be correct. Not that it really matters for most of the appliances anyway. The same on this clock. It's got a ridge down there, but that's completely unpolarized appliance, it doesn't matter. The open rail tape deck is a Sony TC6350. TV is a Sony, but I don't know what the model number is of that. The speakers are Pioneer PAX A16, and those are mounted up at the head of the bed with a light between them, adjustable light. The radio receiver amplifier is a Sony STR 6500, and I brought one along so we can have a look at it. This one is in not very good shape. The power switch here is damaged. It's gone loose, and these pieces fell out the bottom when I first got it, and those are parts of the switch. So I put them in that bag, but I think we're still missing other bits. Let's investigate that. It's very old school. Something's happened with the tuning. So quite disappointed. The power cable was in such bad shape that I had to cut it off and throw it away. The insulation had gone all hard and snapped where the cable was bending, and it had also gone all sticky and dusty and horrible, so that had to get thrown away, unfortunately, which is quite sad because it has a really neat design on the plug. I can show you a photo of one on a TV there. So what we'll do is I'm going to replace it with this cord. It's not a Sony one, it's Hirakawa, pretty common power cable manufacturer, and we'll just cut that off and we'll install it, and then we can try this out. I have no idea if this works or not. It probably hasn't been powered on for many years. It's very old. It's probably all the capacitors have gone bad. There's something up with the tuning control. I'm not sure why that's jammed. Feels like there's something jammed in here, because that will still move. Take the knobs off and have a look. Let's have a look underneath. It doesn't have a bottom. It didn't come with one. I suspect when they're installed in the capsule they don't need the bottom or the top. I wonder if they chose this model for some specific reason. I have no idea. The interesting thing is the transformer has a tapping for 120 volts as well as 100 volts. And I think that is just wired out to nothing. The 121 is the orange wire, which I think is that, which doesn't go anywhere. Whereas the yellow wire is the 100 volt winding, which is the one that goes over to the switch. And then interestingly, they've got a green wire for the line into the switch. All the wires in here have gone sticky as well. It's not very good. Let's change the power cord and then we'll decide what to do. It might be worth trying to bring this up very gradually on a variac to see if there's any excess current draw, because the caps might want to part company. Let's see. Oh, we're going to have to bypass the switch also because that's wrecked. I was thinking we could just backfeed into the outlet there because it's an unswitched outlet, but that's kind of dodgy. But we still have to do something about the switch anyway. You can see there that the whole body of the switch is snapped off from its mounting. Okay, we might actually have all the parts of the switch here. The two contacts and another little rod that I don't know what that does, but on the back of there is the two springy bits that will, insulated parts that will rock over the contacts and make them flop side to side. So I don't think there's much more to it. There's a capacitor across that to just slightly reduce the arcing on the switch. There's another similar switch here, but internally that is not similar. It's one of those leaf rotary things. got one of those really difficult to release cable clamp things, but since the wire's gone so hard, I don't think we can clip it, or I don't think we can pull it through, because normally the way to get those out easily is just yoink the wire through the grommet thing. There you go, like that, and then that will come out. Yeah, it's gonna end up all messy. Making a mess of this old equipment. People are gonna be annoyed. Get some leverage on that thing. Okay. Wow, that's amazing. That's really tight. I don't know why that's such a tight fit. Is that just how these things were back in the day? Well, it definitely has been glued as well. Guess that's part of it. And interesting, that single outlet there is riveted in position. That's pretty strange. Okay, we'll get soldering iron into that and we'll see what we can do. Everything's all sticky from that wiring. Cutting off a nice power cable. That's a bit sad, isn't it? I'll try and wire this up right so that the neutral side of the outlet is still on the correct side. It's just going to be really hard to put that back in. Anyway, let's attach the wire first before we try to put that grommet thing back in, because otherwise it's going to block the access hole that the access way we need to see what's going on down there. Now, I'm going to have to get a bit more solder in there. Get a good gooch solder into there. So this is so ancient, it's dried out. Wow, the wires, the main AC wires weren't bent over at all. The conductor was just poked through the hole and soldered, and that was it. I wonder if this one's been in a bad environment and that's what's led to the decomposing of the plastics. It's a bit disappointing, a bit sad. But it is very old, 50 years or so. So I guess what else can you ask for? Okay, let's tin these wires. Feed solder into the wire. Hope that the flux can eat through the crustiness of the years old wire. Yeah, not too bad. Just cut that back a bit. Okay, we've got a nice wire now. Now we can solder that in. Got to remember to poke it through the hole. Might add a little bit of fresh solder onto those terminals first. Get down there without wrecking it. Got things all around the wrong way. Now I'm going to melt those wires there. Bend all that stuff out of the way while holding that in the right place and poking this. Perfect. And the other one. Perfect. Now we're going to have to bypass the switch. I guess you can't even see what's going on down here. Should have had this zoomed in. So those two wires are now perfectly attached to the back of the receptacle. And we've got this cord clamp thing here. which we've got to try and squeeze through that hole, which is not big enough for it. That seems to be the problem. Work on the fact that the heat is transferred up through the copper a bit, so that this wire has gone a little bit softer than it would normally be, so it's easier to squeeze this thing around it. There's this proper tool for putting these things in, but even that probably won't help in this case because it's so tight in the hole. There you go. Awesome, so we've got a nice new power cable, well, a nice period correct power cable on the amplifier, but we have to bypass the switch. I might just do that in a kind of budget way for now. Just lose that. Although, if we do end up fixing the switch, it's going to need to be long enough. Now, what I'm going to have to do is pull the lever off the switch. That brown lever there must be able to come off. I think it's rusted on, unfortunately, because in order to get the front panel off, you'd have to take those levers off. What is that? Ah, that's the little thingies that I was hoping wouldn't fall out of the switch. They've now fallen out, and the springs have disappeared as well. Okay. Very boring video. Alright, we'll just stop this for now. Okay, I was able to get the lever part of the switch off. That pulled off okay using the pliers. And now the shaft can come back through. And we've found out now what that little tiny rod thing that was in this packet of goodies does. That went through there so that this had something to swing on or against. But unfortunately, I think I've lost the springs that were in there, which these little bits went into. And there were two springs that caused those to push out so that they would rock against the contacts which go into the back half. So I need to find those springs, otherwise it won't be possible to rebuild the switch unless we can find some new equivalent. There's one of them. There's the other one. Okay, the springs have come out. Okay, so I'm going to pack away the little bits of the switch for later on. So that's all safe. Need to clean up this mess. And I'm going to bypass the switch. I think we'll just put a little, like, thingy over that, whatever you call it, a screw-on thing. Okay, I found a terminal thingamabob. And I've also found a little speaker, so we can try it out. So get that sorted. $16 ohms. It's from a computer. I think that's like an HP computer maybe. To this little terminal block, we'll just put the wires into that and that will keep them safe, keep them connected. Yeah, what a shame to have a damaged switch. Someone was rough with this thing at some point, I guess. Wow, there's a lot of gooey wires in there. Alright, let's connect up the speaker and then we'll try powering this thing up. See what it does. Oh yeah, the tuning thingamabob doesn't work. We still have to work that out. The dial light, it's got gloopy stuff on it. It must have been a coloured light bulb that's really melted its colour off. I think there's another dial light. Oh, at the ends it's those ones that look like glass fuses. Would have been in there. You can see that blue wire going to it, and at that end as well. Here's the back panel. So it's got RCAs as well as a DIN plug for tape, screw terminals for aerials. It's got the AM rod antenna there, and it's got speaker terminals that are also screw terminals. There's the rating plate. An FM stereo, FM AM receiver, 76 to 90 megahertz FM. Okay, I'll wire up a speaker. Those should have got 2 speakers out. This will be a right channel. That'll be a right channel, that one. And we should have got 2 that were the same. Anyway, this is another speaker. I don't know what its rating is. I don't think this video went as well as I was planning. Scripted stuff doesn't seem to work. Doesn't flow. And then this stuff, I don't know if this is flowing either. Anyway, we tried. So what we need to do is bring in, hopefully those can just, yeah, that one's shielded. That one can sort of hold itself there. Now we need to work out what's wrong with the tuning knob. Oh, it's just bent a little bit. Okay. So it will work. Just these knobs are all push on. Okay, there we go. I just need to pull it out a little bit. Yeah, because the screws for holding this front panel on are under those larger knobs. You can see there. And they'll be the same under the volume. It's one of those split volume controls where the you can do the balance by turning them independently. That's easy. So the reason why that was the tuning dial was getting stuck is because that screw that holds the front panel on was banging into these webs on the knob. So having it not pushed on so far, it's fine. That's good. So we didn't have a problem there. You see that good old variable capacitor there with the plates moving in and out. Right, let's juice this up. Bring in the power meter, but we're going to have to put that before the variac, unfortunately, because we need to... The power meter doesn't start until above about 80 volts, so that's not going to work. So we have to put the power meter first, then the variac. Variac has a polarized plug on it, so I need an extension cord. This is variac here. It's got a polarized plug, so I need to use this extension cord to undo the polarization. So we'll turn that on. Okay, so that takes about 0.6 watts. And it's set to 0. Small little thing that I 3D printed the housing for. So we'll plug in our new cord to that. And we'll wind it up and see what happens. We're over halfway. Oh, the dial light's coming on. It's about 13 watts. Don't hear anything from the speakers. That's quite amazing that the lights work. I think the bulb there's blown, but the one on that side is still glowing a bit. Seems dead though. Not even on AM. Oh, you have to have the function in the middle to do that. Seems to be dead, unfortunately. It might be a voltage regulator or something. I was just touching the capacitors to see if anything was heating up. A couple of things I wonder, is the headphone socket disconnecting the speakers and that's why we don't hear anything? That's possible. Or is the power supply dead? We may be able to measure the power supply from the underside. So there's the main cap there. Let's do a bit of measuring. Okay, there's a capacitor there. That biggish capacitor, we'll measure that. See if that's got any voltage. 54 volts. Okay, is that good? Now there's a whole bunch of other stuff here with a ground on one side. 5.4 volts. 3.6 volts, 3 volts, 3.7 volts. Doesn't sound very much, does it? gonna have to look up a circuit before I can do much more there, because I'm not sure what the power supplies are supposed to be. Depends if there even is a circuit for this model readily available. It's pretty uncommon. The output transistors for the amplifier are on this separate heatsink, wired away from the board. So it's got 50 volt caps here and here, and these ones are 35 volt. And from the other side it's real hard to know where they go, where they are connected, or ulnar capacitors. Yeah, I wasn't able to find a schematic from a quick bit of looking. Suspecting there's some sort of power supply issue on this thing. Staring at it for a while. This board here seems to be the power supply board. Well, the rectifiers and initial smoothing. So it looks like, you can see on the bottom of the transformer there, it says 7 volts blue and blue wire, so that will be just the dial lights. And then the other winding says 44 volts, 0.65 amps, and it's red, red, and presumably black as the center. So that would be, presumably that's center tapped 44 volts, which appears to be what we measured across that capacitor when it was rectified to 50 whatever. And it looks like those red winding wires coming off the transformer go onto this board here. There must be some kind of rectifier. Yeah, this old school thing. There's some resistors there. Yeah, so that there's some kind of dodgy ass old school rectifier. I wonder if that's pooped itself. Wouldn't be surprising. Three terminal device. Bend it out and look at it. This is international rectifier, old school rectifier. There must be another wire coming across. Okay, so the rectifier must work because we measured the right voltage across there with the black one which comes out of the transformer on one side of the capacitor. Then this rectifier, so it's just a half wave rectifier. So that's actually 44044, and that gets turned into this. And then there's a transistor there in that CAN package, and that's joined up to something, I don't know. Goes onto this board here next. So yeah, it goes. Oh look, that's almost touching there. That's dodgy. Yeah, so it goes on that blue wire, the positive 40, 50, whatever volts, onto the CAN of that regulator thing, transistor, and then the other side, yeah, it goes into that, some voltage dividers, and there's another diode, which I'm wondering if that is a Zener, which might have pooped itself, and then there's a bunch of resistors. The transistor feels very loose. I think it's just got very flimsy legs. An SV-03 diode. Yeah, I don't know. Without spending a long time tracing all that out and then working out what voltages should exist on different points, we're not really going to get very far, unfortunately. That, unless we can find a circuit which just tells us that stuff without having to work it out for myself. But my suspicion is there's a power supply issue. I'm not going to bend that rectifier back because, yeah, it's going to snap off if I do that. Don't know about how much of that video is going to end up in the final thing because there's a lot of just waffle there. So I measured sort of 3 and whatever volts on that, but it doesn't really seem right, does it? It seems like it should more likely be 12 volts, 9 volts, the sort of voltages that you get on stuff. So there are outputs there, unlabeled, which go to that board, presumably that going to that board, and this going to somewhere down there. Oh, there's a stereo indicator, which is little tiny twisted wires there go down to some sort of light bulb down there. Yeah, that then's got a red filter on it for the FM stereo. So that comes off that yellow wire there. Yeah, so we should be able to get a rough idea of the voltages by the capacitor voltages. There's 25 volts, 16 volts, 50 volts, and whatever that big blue one is. Yeah, it's nothing like what we saw though. Yeah, I think there's something up with that transistor regulator thing. I think that's what the problem is. I think unless that's supposed to drop it down to 7 volts. Whatever it was I saw in there. 6 volts? It doesn't sound that unusual, does it? But then there's only 3.6 going to that circuit, which is kind of low seeming. Okay, we're going to relieve the investigation of this there for now. I need more information or to spend time tracing this out in order to get much further on this. But anyway, it's the official amplifier from Nakagin Capsule Tower Rooms. Right here. So I need to restore that so I can build my own version of those rooms. Got all the other bits. Hopefully that wasn't too much of a mess. Felt like it went a lot more haphazardly than I envisaged. Seems like scripting videos is not a very good idea. It's easier just to let them flow. Nakagin Capsule Tower. Unfortunately, it is disappearing. So many things we forgot to talk about. So when you normally look in the photos, most photos you see of it, you're looking this way from the street outside, so that would be the front of the building this way. So the A tower is on your right when you see it in the pictures, which is the taller one, and the B tower is the shorter one. That's gone completely now, and they're working on removing the capsules from this one, and it will be gone within a couple of months, which is pretty sad because it's very iconic and it's very unusual and interesting. Anyway, if I do get around to looking into this, I'll make another video on it, and otherwise we'll go back to looking at video cameras and VCRs. Oh, and one more thing before I forget. Expect to see more videos about plugs, sockets, adapters, cords, other electrical fittings, because obsessions are hard to shake. Got some stuff here to take a look at in another video, which hopefully will be interesting.